Hello, and thank you for joining us for this exclusive webinar on professional sound level measurements in an industrial environment. The team at NTI are experts in and passionate about sound and noise measurement. Since 1976, we have consistently delivered reliable, quality products. Our vision is to create innovative and exceptional products that provide the best solutions, shape the industry, and simplify our customers' lives. When specifically addressing noise in an industrial environment, we consider both quantity and quality. On the one hand, we determine if the quantity of noise should be limited, as is the case for the protection of employees' hearing and reducing the environmental noise. On the other hand, we report on the quality of sound, as is applied, for example, in determining the state of a machine based on the frequency spectrum of the sound produced by that machine. Today we are fortunate to have our technical director, Marcus Becker, here to walk us through the basics of sound measurements and to show us practical application examples for sound measurement in an industrial environment. Feel free to submit questions at any time. After his presentation, Marcus will be answering questions. And now I hand over to Marcus.
Thank you, Paul, and a very warm welcome also from my end. Just before I start with the presentation, please notice that at some points I will refer to this instrument that you can see here on the left-hand side, the XL2 acoustic analyzer. However, I will not go into the details of that instrument. If you want to know more about it, please don't hesitate and contact us in the question section or by sending us an email. Well, we have prepared for you a presentation about the basics of sound level measurements. We will also talk about typical applications and practical aspects, and also spend some words about auxiliary equipment such as microphones or other stuff you might need for executing and documenting your measurement. Why are we interested in measuring sound in industrial environments? Well, there are three major reasons that you may encounter. The first one would be to protect your employees against excessive noise. This can be demanded by a legal body, and of course it is also in the interest of the owner of the company, the boss. Then you might be interested in monitoring, for instance, workplace noise over a longer time period, which is of course related to the first topic, or which is a completely different application. You may be interested in analyzing the noise of machinery, be it for optimizing the performance of that device or by finding some problems in it. Well, the basics of sound measurement include the weightings, and here I want to spend some words about what types of weightings can be activated in an instrument and what do they mean. If we first look at the left-hand side of this slide, you will see the frequency weightings. And as you probably know, our human hearing perception is in that way limited that when it goes into lower frequencies or higher frequencies coming to the 20 kilohertz frequency, for instance, our human hearing perception declines. And these filter curves here, which you see here, they represent this behavior of the human average hearing. Especially the green curve, the A weighting curve, is a very popular one, and that represents that hearing perception in the standard loudness range or level range, for instance, in a conversation of two people or in a production hall. When it comes to very high levels, then the blue curve, the C level, the C frequency weighting would be applied. And in addition, I have also plotted here the Z weighting, which is actually linear weighting, which means that this is the technical correct measurement of the sound pressure level without any frequency weighting. The selection of either of these weightings depends on the legal requirements and of the application. I will spend some more words about that later. Then, in addition to the frequency weighting, we also have a time weighting. And what does that mean? Now, if you look at the top picture on the right-hand side, we have this is just a schematic picture. We would take, for instance, the blue curve as a very quickly rising sound pressure level. And the question now is, how quickly does the test instrument react to that very steep increase? And here we have different time weightings, I for impulse, F for fast, and S for slow. So the inertia of the test instrument is determined by the corresponding weightings. The inertia, how quickly it reacts to such a rising edge, and how long it keeps the displayed value on the screen so that you can read it, so to allow the readout of a short impulse, for instance. Actually, the S, the slow weighting, is applied in cases where you have low frequency modulations, for instance, speech, whereas the F, the fast one, is the most frequently used weighting, time weighting. The impulse weighting actually is no longer part of the standards, but you will find it in some instruments, for instance also in ours, if it's required. Then on the lower part of the right-hand side, you see a very important measure, and that is the LEQ. And that stands for the equivalent continuous sound level. And that represents the quantity of a long-term sound level exposure over time. So when you are, for instance, in a concert, or in our case here in an industrial environment, you want to know the overall amount of sound that has come to your ears over time. So in contrast to the instantaneous level, you want to know the long-term average, and that is what the LEQ is standing for. So LEQ actually is maybe the most important, the most frequently used measurement, and also the most frequently required measure by the standards and laws. The LEQ can, of course, be combined with a frequency weighting. For instance, LAEQ would be such a typical measurement. Another aspect to be considered is that you can measure the sound level in, or let's say visualize the sound level in two different ways. You can measure it as a single value, as you see here on the left-hand side. So you would summarize the overall sound pressure level within the typical audio band, which starts from 20 hertz and goes up to 10 kilohertz, representing the typical human hearing. So this is a wideband level with the different weightings, as I just explained. Or alternatively, we can also take a look at the spectrum of this sound that you want to measure. And this spectrum gives you, of course, more detailed information about the characteristic of that sound. Our human ear would not be able to differentiate this fine resolution that you see here on the screen, but by looking at it, you will be able to find some interesting information. For instance, if you have a very sharp band-limited noise in your machine, you would see it here on that screen by a very highly uprising bar in this graph, and you would in that way be able to identify the frequency in which this this whistling noise, for instance, is created. Coming back to the application examples, here on the left-hand side I have two typical applications for analyzing machinery noise. So the first one would be that we want to analyze the behavior, the characteristic of a device, for instance, a motor. And for that purpose, we might execute a wideband level to know the overall level of that machine, but also in many cases we want to know the characteristic of that machine as just explained, for that purpose, we would probably choose the spectrum, third octave or octave resolution, depending on how accurately we want to go into these details. And in the middle part, or the right-hand part of the machinery noise analysis, we have a different application. Here we want to analyze the effect of a measure that we have applied. For instance, we would like to know if we build an acoustical shielding around the machine. We want to know the impact. How much does this shielding really reduce the noise? And for that, typically we would rather go into a wideband level measurement to know the overall impact, and maybe also a spectral analysis to have more detailed information about the characteristic, the performance of this shielding. On the other side, shown here on the right hand in this slide, we have an environmental noise assessment. So here we want, for instance, to measure the sound exposure level or the noise dose. This is, by the way, required by some laws and national standards. I will come back to that as well later. So here we are talking about the long-term impact of sound, of noise on the human hearing, and the goal, as mentioned before, to protect our employees from any damage. When we talk about measuring sound level, a key factor, of course, is the microphone that we are using aside of the instrument. Well, the first question we have to ask and to answer is whether we need a class 1 microphone or class 2. What is the difference? I have shown here just a very one example of the differences between these ones. The class 1 microphone has a much tighter limit, frequency response limit, like the class 2. So the class 1 microphones are highly linear microphones with a very high long-term stability. And, if you want to execute or have to execute a measurement that may be applicable in a law case, then you definitely have to opt for the class 1 microphone. Class 2 microphones are, of course, a little bit less expensive, and they are quite well and applicable for assessing noise, executing analysis, for instance, machinery noise analysis, as long as you're not obliged to do a long-term measurement for exposure of human beings. Then we rather would recommend the class 1, as said before, for this liability reason. Both types of microphones, by the way, should be are omnidirectional, which means it does not matter from which end the noise is coming to the microphone capsule. It will always result in the same measurement value. Then an important part, as you see here on the right-hand side, is that you have to calibrate the microphone sensitivity. What does it mean? The microphone capsule actually is a device that translates the physical sound pressure level from the air into a voltage, and this voltage then can be analyzed by the test instrument. But the ratio by which this translation, this conversion of sound pressure into voltage is done is individual for each capsule. So the test instrument has to know this ratio, and that is what we call the microphone sensitivity. And for that reason, all our microphones, for instance, from NTI Audio, are calibrated, factory calibrated, and the corresponding values are saved in the microphone itself, so that the instrument always knows exactly what sensitivity the connected microphone has automatically, so you don't need to enter that value. If you have a class 1 microphone and you want your instrument to be calibrated once per year, what is recommended, then you have to may have to send it, for instance, to a lab, to a accredited lab that can execute this calibration, or you can send it to us. And in addition, if you want to verify whether the saved value is still applicable, you can use a calibrator, a microphone calibrator. This is the black box that you see here on top of the microphone. This is a temporary used part to verify the correct calibration. There are actually some cases where you need to recalibrate the microphone yourself. And for instance, this is maybe the case when the relative humidity of your environment changes dramatically. It's completely different to the previous measurement. So just to adapt the microphone sensitivity calibration to the environmental situation, when the humidity plays a major role, you might need to recalibrate the system with that device. Or another example would be if you have a place to measure with a very high altitude on the top of a mountain or something like that, then you would need to recalibrate the microphone as well. Then before you start the measurement, you need to adjust the input range. And here we're talking of the sensitivity of the test instrument. And that means that the test instrument, of course, should measure your sound level as accurate as possible. And for that reason, because the dynamic range of sound is a very high one, we need to adjust this input range, the acceptance range of incoming sound levels, to the instrument accordingly to the application. Here on the left-hand side, this scale shows 3 possible level ranges. For instance, the green one to the very left would be used for very low sound levels when you are in a very quiet environment. On the other hand, if you are in a very loud environment, if you have to measure the noise of a starting airplane or in a very loud rock concert, you would rather go for the orange bar, which is the higher level range. So here you are sure that you will capture all these high levels accurately without clipping. But on the other hand, you would miss very, very low sound levels, but in those applications, this does not matter at all. So adjusting the level range, and if you look at the middle picture, you see here this red rectangle that shows you where to adjust the input range on our instrument. That needs to be done before you start the measurement. Another preparation you may have to apply would be to the decision whether you want to log your measurement, whether you just want to execute a measurement and note the final value, or whether you want to log the results over time. Here you see the logging screen of the Excel tool, and there are a couple of settings you can adjust. In the lower part, you see the values that you want to log, the different weightings. You can compile this selection individually. Then you can take the decision whether you want to add the spectra. Remember these octave or third octave spectra to the logging, or you can even record the sound during the measurement so that you can listen to the sound after you have executed the measurement. You can re-listen to it. You can identify certain events by listening to that wave file. And last but not least, you have to make up your mind about the log interval, which means at which time period these measurement values shall be saved on the SD card of the XL2 instrument. When we're measuring or analyzing machinery noise, we would go to a very low interval, 0.1 second, so which is 100 milliseconds, for instance, whereas for long-term sound level exposure, you can select a longer period, 1 second, 5 seconds, 10 seconds, that's up to you. But this setting also has to be done before you start the measurement. Some practical aspects when you want to measure, for instance, machinery noise, especially from very loud machinery, we recommend to disconnect the microphone from the instrument directly and connect it through a cable. This has 2 advantages. First of all, you avoid acoustic reflections. As long as you hold the instrument in your hand, your body will reflect incoming sound waves, so that will compromise the test result a little. So by detaching the microphone and connecting it through a cable, you avoid these reflections. And secondly, it allows you to avoid your own exposure to harmful environments, to very loud noise levels. Secondly, please keep in mind that when you want to do a comparative analysis, you must make sure that the microphone is placed really in the precisely same position of the corresponding measurements. So let's say first measuring the sound of this generator and then repeating that measurement when you have applied some shielding around it. The microphone has to be in the same position towards the generator to really allow you an accurate and relevant measurement. Then some words about the sound exposure level that I already mentioned before. Sound exposure level actually is the integral over time of the squared sound pressure. So this tells us something about what we also can call the noise dose, the amount of sound that has come to our ears over a certain period of time. And there are different standards. I have listed two of them here in the European Union or in the United States that prescribe specific thresholds and maximum levels depending on the application, depending on the place where you are measuring this sound exposure level. So in the table below you see, for instance, the thresholds at different settings. For instance, if you exceed the 80 dBA level or the LC peak level of 135 dB, then you have to offer to your employees hearing protection. If we exceed the 85 dBA, you even have to enforce your employees to wear a hearing protection during their work time. And if the level is getting even higher, you must make sure that that hearing protection is optimized to the spectrum, to the characteristic of the environmental noise. There are some other things to consider when you execute a sound exposure level measurement. For instance, you have to consider the break times of your employees when they get out into the room to have a snack or something, so you have to follow them. And these different levels have to be weighted in different ways. And for that purpose, we have prepared an Excel sheet where you can enter the corresponding results and also the different weightings. So these are different weightings that depend on the legal situation, and this Excel sheet will then calculate the corresponding correct value. Coming back briefly to the standards, the two ones that I have listed here, by the way, OSHA stands for Occupational Safety and Health Administration, HC stands for Hearing Conservation, and PEL for the permissible exposure level. These are national standards, or the European standard you see up there, the 2003-10. They are differently interpreted by the corresponding countries in Europe or in the States. So that is something I cannot cover all of these different solutions in the corresponding places. Just make yourself acquainted with the applicable law in your location. Coming to the documentation of your test results, of course you want to have a proof in your hand at the end of your measurement that shows that you have done everything correctly, especially when we talk about sound exposure measurement. The good news is that this is a very simple task. The Excel tool saves all the data if you have activated the log on the SD card, so you can just unplug that SD card and plug it to the corresponding port of your PC, or you can also use the USB interface of the instrument to transfer that result data into your workplace. And the log files are saved in a formatted text file, so that's a very simple way you can directly import these files into your spreadsheet calculation program, as for instance Microsoft Excel. And actually NTI Audio has also prepared some templates for different applications, and you can download them for free from our website as soon as you have registered there. And these templates simplify the import, further simplify the import of the files and the graphical representation and all this information that are related to the measurement. Summarizing what I have just shown to you, first of all, it's quite obvious when you want to do a professional sound level measurement, you need professional test equipment. This is quite obvious. The technical requirements for a precise measurements are pretty high. They exceed, for instance, by far the technology that would be implemented in the smartphone. So you have to go for a professional equipment for this application. Don't forget to calibrate your test system when you are looking for accurate and legally liable results. Don't forget to adjust the input range of your instrument properly to avoid clipping, or on the other side, the effect that the sound level of a very silent environment would be too low for the instrument. Then select the applicable and the relevant measurements and weightings for your specific application. Make sure that you execute the test correctly, for instance, by p-patching the microphone or placing it in a reproducible position. And if you need to document all the measurements, it is recommended to activate the logging, because that will allow you not only to get the final value of your measurement, but also get a glimpse on the cause, what has happened during this measurement period. Well, I'm at the end of my presentation, and I would like to hand over the word to Paul now.
Marcus, thank you very much indeed for your insight into the field of professional sound level measurements in an industrial environment, and of course giving us some tips on what the engineers should look out for. Now I think let's get on with the Q&A session. We have a little time on our hands, so I'm going to kick off with questions as they came in. The first question we have for you, Marcus, is what is the fastest sampling speed of your equipment, specifically to detect peaks?
Yeah, thank you, Paul. That's a very interesting question indeed. And the answer is that our test instrument, the XL2, has a sampling rate of 48 kilohertz. And according to the Nyquist theorem, that means that it will detect all peaks, all incidents up to a frequency of about 22 kilohertz. The bandwidth of the instrument is limited to 20 kilohertz, so you will not miss any peak in the audible range, and that is what is the important aspect of these measurements. Also, the legal standards and laws require such a resolution.
Let's have a look here. We have another question from our attendee, particularly, are these piezo microphones, and which is the best microphone for impulse measurement?
First question, piezo microphone, no. These are electret microphones, pre-polarized electret microphones that we are selling. You can also connect other microphones to the instrument as long as they have either a 48-volt phantom power or an ICP supply. The disadvantage of using other microphones is, however, that they don't have the chips included, or they are not compatible with our instrument. So in that case, you have to make sure that this microphone sensitivity would be entered manually into the instrument correctly. But it's not piezo, it's electret microphone. And the best microphone for impulse measurement, the answer is quite simple. Any of our measurement microphones would be suited, because the bandwidth of these microphones is identical to the instrument, so you will not miss any impulse by using any of our microphones.
Right, excellent. I see there's been one or two questions coming in about the sound. If people are having trouble with sound, just drop us a quick notice in the Q&A section, but I hear from the technical side that this should be sorted out by now. So let's have the question then was possibly to do with the loss of sound, short loss of sound there. Can you discuss the time of the measurement setting again? Can you discuss the time of the measurement? Does that make sense to you, Marcus? Time of the measurement setting.
I'm not quite sure whether
a bit broad.
That refers to the logging.
I'll tell you what we'll do. The questions like that seem to be a little ambiguous, and also for questions that we're not able to get to in the time that we are assigned to us, we'll certainly be getting back to each of the attendees by personal email so that we can discuss and iron out any outstanding questions. So, for example,
one idea. Sorry, Paul. Just one idea comes into my mind.
Certainly.
Just suppose that I'm understanding the question correctly. It is important to adjust the input range and to adjust the logging before you start the measurement. You cannot do that during the measurement because the instrument has to be set to that before you start. But go ahead.
Right. Okay. Right, I see. Let's have a look at the questions, and there are lots of questions coming in, so I'm trying to be fair and choose the ones that come in first. My screen is refreshing quite quickly. Here's an interesting question. Does the XL2 support high-resolution FFT analysis?
Yes, it does. We have an FFT analysis included in the instrument by default, and you can even extend that functionality with a higher resolution and with some limit settings on the FFT as well by buying an option, which is just a license key that you install in your instrument. The answer is yes, FFT analysis is by default supported by the XL2.
Right. And here's a general question about, here's an attendee who's very keen to go out and buy one of these instruments, so you've obviously done a very good job here, Marcus. Instrument analysis, spec sheet, class 1 microphone, where to buy, cost on each, loads of questions, and I think that we'll get back to you by email on that question because there are a lot of questions to answer then specifically on. Do you want to say something about distribution and purchasing, Marcus?
Yeah, just one short note. If you visit our website, www.nti-audio.com, you will find the spec sheet for download. You will find the contact information in your country, and you will find all the information about these class 1, class 2 microphones, and so on.
Okay. Thank you very much indeed. Do you recommend using an airball over the microphone when performing outside measurements? How do you protect the microphone?
Yes, generally yes. We recommend and we deliver these windscreen, we call it, with every microphone that we sell. So you will receive that part by default, and we recommend to use it. That's correct, because the impact of wind without such a windscreen would go into the measurement. It would falsify the measurement. So by using that windscreen, you are on the safe side.
Right, and that foam that's put around, and it's not just a windscreen, I understand it also is water resistant and IP65 rated.
No,
right?
In such cases, when you want to do an outdoor measurement which may be exposed to rain and strong wind, then you need an extra protection for the microphone. We do have that, an outdoor microphone kit that you can buy from us. You just combine it with the microphone, for instance, the class 1 microphone, and then you have full protection against heavy rain, against wind. That's a little bit bigger than this windscreen I was just talking about.
Okay, many options available for protection from the elements outside. And then there's a question that's come in that asks if we can measure vibrations as well.
The answer is yes. I have to admit that the XL2 has not been specifically designed for vibration analysis, but you can connect a vibration sensor to the instrument if it's, for instance, powered by ICT. We do already also have a vibration sensor in our portfolio range, but keep in mind that the measurements are a little bit restricted in that case to voltage, for instance, or to FFT. So we don't have this full range of typical vibration analysis of specialized instruments. But yes, you can actually also measure vibrations with the instrument. Right,
thank you. And on to the next question. If you set up for LAF, which is level A-weighted FOST, response time waiting, how long should you take the sound reading? The attendee says that they usually set up an LAF for 10 seconds. Should they be taking a shorter reading, perhaps?
The answer is this. The LAF is a typical measurement or setting for measuring the instantaneous sound level. Well, the true instantaneous sound level is, of course, can change extremely quickly. So it's impossible to follow that by, even if you would have a display that can show every single result with a 48 kilohertz sampling rate, you could not follow that by looking at it. So there is a small inertia, but it does not need to be 10 seconds. I think we have a refresh rate of 10 or 20 per second, so we are pretty quickly in showing that instantaneous level. But if the incoming sound is changing too quickly, then it gets really difficult to read out a relevant value. But then you would rather go for the slow weighting, for instance.
Right. Perfect. Thank you very much indeed, Marcus. I think that's all we have time for now from the question side. There are some technical questions which would probably be better answered directly one-on-one through email. So we're going to have to wrap up the webinar right now. Marcus Becker, Technical Director of NTI Audio, thank you for spending this time with us today. To find out more information regarding sound measurement in an industrial environment, please feel free to visit nti-audio.com or drop us an email with any questions or specific applications. You will be receiving an email from us with a link to the on-demand version of this presentation, where you may also access a PDF of PowerPoint and the Q&A transcript. Again, thank you for your time.
Thank you from my end too.